Hello everyone, welcome back again to Bio Tutorials. In this video we're going to tackle about the chapter 11, the combined heat transfer. What is combined heat transfer? In combined heat transfer, it combines the conduction and convection heat transfer. The conduction process transfers heat generated to the surface of the component, and convection establishes heat transfer to the surroundings. So for better understanding, convection combines conduction heat transfer and circulation to force molecules in the air to move from warmer areas to colder areas. As the molecules closest to the heat source become warm, they rise and are replaced by colder molecules. So we need to answer this problem regarding with the combined heat transfer. Example number 1. Example number 1 on the combined heat transfer. Heat is conducted through a material with a temperature gradient of negative 9,000 degrees Celsius per meter, and the conductivity of the material is 25 watts per meter degree Kelvin. If this heat is convected to the surroundings at 30 degrees Celsius with a convection coefficient of 345 watts per square meter, and then determine the surface temperature. And if the heat is radiated to the surroundings at 30 degrees Celsius, determine the surface temperature. So to solve this one, we need to use this equation, and in this case, the convection and conduction are only involved. And we have the negative thermal conductivity times the area times the temperature gradient, which is 9,000 over dx, which is our temperature gradient, equals the heat transfer multiplied by our area, which is 1, and multiplying it again with the temperature at state 1 minus the temperature at state 2, which is temperature at state 1 is unknown. So by plugging this into our calculator and using the direct solution or the shift solve, we get the temperature at state 1, which is 682.17 degrees Celsius. And in this case, conduction and radiation are involved. So the heat conducted is equal to heat radiated. Excuse me. Negative 25 as our thermal conductivity multiplied by our radiation times the temperature gradient of equal 5.67 multiplied by the temperature at state 1 over 100 raised to 4 minus 303 over 100 raised to 4, and we get the temperature of surface temperature of the surroundings at 30 degrees Celsius, which is 14 Kelvin or 1139 degrees Celsius. So that's it. Thank you for